I want you to think about the greatest story ever told. No, not a book or a movie. I'm talking about the story of our universe. Now, what if I told you that in this epic tale, 95% of the main characters are, well, they're complete strangers to us, hiding in plain sight. Let's begin the chronicle of this cosmic mystery. Okay, let's just jump right into the deep end, shall we? You, me, this planet, every star you see in the sky, all of that, it's only 5% of what's actually out there. 5%. The other 95% is this huge invisible empire, and it's ruled by these two phantoms, dark matter and dark energy. You can't see them, you can't touch them, but we know they're there. So, how in the world did we even find out about this hidden realm? Well, for centuries, our story of the cosmos was one of serene, simple perfection. Thinkers like Isaac Newton saw the universe as this perfect, eternal clockwork, something that was always there and would always be there, completely unchanging. But you know, this perfect clockwork had a pretty big problem: gravity. Gravity always pulls things together. So in a universe that's just sitting there, why didn't everything just, collapse into one giant clump? For that old myth to hold true, there had to be some kind of perfect unknown force pushing everything back. And this is where the plot really thickens. A new titan arrives on the scene: Albert Einstein. His groundbreaking theory of general relativity was about to rewrite the laws of gravity, and in doing so, it threatened to just completely shatter that myth of a static cosmos. Here's the thing. Einstein's own math, his beautiful equations, were telling him something radical. They were predicting a universe that was alive, dynamic, one that had to be either expanding or contracting. This clashed with all the accepted wisdom of the day. So, to keep his universe static, he introduced a little, a fudge factor that he would later come to regret. He called it the cosmological constant. It was basically an anti-gravity force he just plugged into the math, all to keep that old myth alive.
In this timeline, it shows a really fascinating intellectual struggle, right? In 1917, he literally bends his own theory to fit that old static model. But just wait. By 1929, brand new observations from the heavens were going to force his hand. And by 1931, he casts his own creation aside.
So what did he think about it later on? He called it the biggest blunder of his life. Can you imagine? He felt like he'd missed the chance to be the one to predict a dynamic, expanding universe. But let me tell you, the story of this so-called blunder, it was far from over.
That's because while Einstein was wrestling with his theory, a whole new generation of cosmic seers were pointing their telescopes to the sky. And what they were about to see wouldn't just challenge the old myth. Oh no, it would shatter it completely.
This was the moment. 1929. An astronomer named Edwin Hubble was observing distant galaxies, and he discovered they were all rushing away from us. And the farther away they were, the faster they were going. There was just no denying it anymore. The universe was not some static clockwork. It was a great cosmic explosion, expanding from a single, incredible beginning.
So, boom, the old myth was dead. A new, much more logical story took its place. The universe was expanding, okay, sure, but the immense gravitational pull of all the stuff inside it had to be acting like a brake, right? It just had to be slowing that expansion down over time. It makes perfect sense.
And for decades, that was the story. But right at the very end of the 20th century, a completely shocking new chapter was about to be written. Our observations summoned two new, immensely powerful and utterly invisible entities onto the cosmic stage. A dark pantheon that, we would discover, rules the entire universe.
Get this. The year was 1998. Two separate teams of astronomers were using this very specific kind of exploding star, a Type Ia supernova. You can think of these things as like perfect cosmic lighthouses. They always explode with the same brightness, so we can tell exactly how far away they are. And these teams were using them to measure how much the universe was slowing down. But what they found instead was shocking.
It wasn't slowing down at all. It was speeding up. The expansion of the universe is accelerating. Some mysterious, repulsive force was literally pushing space-time apart, and it was overwhelming gravity. And just like that, what Einstein called his biggest blunder, well, it was resurrected as a stunning, mind-blowing prophecy. This incredible discovery solidified our modern cosmic myth, a story now ruled by two powerful dark forces. On one side, you have dark matter, what we can call the Great Binder. It's the invisible gravitational glue that holds entire galaxies together. And on the other side, we now had its counterpart, dark energy, the great accelerator, that mysterious phantom force that's pushing the entire universe apart.
And this chart, it illustrates this cosmic tug-of-war perfectly. It's happening right now, all across the universe. Dark matter is pulling everything inward, trying to build structures, to clump things together. But dark energy is pushing everything outward, driving that accelerating expansion. And if you look at the chart, you can see, right now, dark energy is winning. Big time.
So, all of these revelations, the expansion, the dark glue, the accelerating push, they are all now enshrined in what we call our standard model of cosmology. It is the modern canon. It's our best attempt at writing the true story of creation.
The official name is the lambda CDM model. That Greek letter, lambda, that represents the cosmological constant, Einstein's revived idea, now serving as the simplest explanation we have for dark energy. And CDM, that just stands for cold, dark matter. This model is, without a doubt, the foundation of all modern cosmology.
And believe me, this model is incredibly precise. This table here, it's using data from the Planck satellite, and it shows the universe's fundamental recipe. We've got the Hubble constant telling us how fast it's expanding today. We have the exact densities of normal matter, that's the baryon density, plus dark matter and dark energy. And when you put it all together, it even gives us the age of the universe, a very precise 13.787 billion years.
So why do we believe all this? Because it works. It is stunningly successful. The lambda CDM model perfectly explains the faint afterglow at the Big Bang. It predicts that huge web-like structure of galaxies we see out there. It totally accounts for the accelerating expansion, and it even matches the amount of elements created in the first few minutes of time. I mean, it just ties all the evidence together in this one beautiful story.
And yet, at the very heart of our greatest scientific triumph lies our deepest, most profound mystery. Our best theory for what dark energy actually is, it's the energy of empty space itself, what we call vacuum energy, a property of nothing. As one physicist so elegantly put it, the vacuum holds the key to a full understanding of nature.
And so, our chronicle has come full circle. We've journeyed from a simple, static clockwork to a vast, dynamic universe completely dominated by invisible forces we've only just begun to name. We have our standard model, a modern canon that just works. We finally have a name for 95% of everything. But what is it? That is the next great chapter in this incredible story, and it's still waiting.